Z-test. Now, let's look at Z-test. Suppose you need to test null hypothesis, mu equals mu naught for a normal distribution with known population, standard deviation. And alternate hypothesis, mu is greater than mu naught, sigma remains unaltered. Suppose x bar is the mean of a random sample of n observations from the population. You would reject the null hypothesis when x bar exceeds a threshold limit c in favor of the alternate hypothesis. For a given level of significance alpha, c should be chosen so that prob value of x bar is greater than c when null hypothesis is true, equals alpha. When null hypothesis is true, you know from sampling distribution theory that x bar follows a normal distribution with mu naught and sigma by square root n. Now, prob value of x bar is greater than c when null hypothesis is true equals alpha. Implies prob value of x bar minus mu naught by sigma by square root n greater than c minus mu naught by sigma by square root n when null hypothesis is true equals alpha. Now x bar minus mu naught by sigma slash square root n follows the z distribution, or normal distribution with mean 0, and standard deviation 1, also called standard normal distribution, hence the value of c minus mu naught by sigma by square root n can be obtained using software or statistical tables. Once c minus mu naught by sigma by square root n is known, the threshold limit can be determined. Knowing the value of c, one can decide whether to accept or reject null hypothesis. The above test is referred to as a Z-test, since the cutoff value is determined using the standard normal tables. Sometimes, the normal tables cannot be used. This will be dealt with in a subsequent chapter. In the earlier discussion, we set alternate hypothesis as mu is greater than mu naught. Sometimes, alternate hypothesis would be mu is not equal to mu naught or mu is lesser than mu naught. These aspects will be illustrated with a contextual example in the next section.